A few days ago, Make.com released a beta version of their brand new AI agent system. In today's video, I'm going to compare it against n8n's AI agents to help you figure out which is the best system for your AI automations. I'll be breaking down the differences across a number of different key categories to really dive deep into what the differences are. And the first one up is the user experience, or the ease of setup of the agents. Creating AI agents in n8n is super simple. So you just click create workflow, you add a first step, so you need some sort of trigger. So we'll just put in a chat trigger. That way you can interact with the agent using a chat interface here. And from there, you just click on the plus, type in agent, and away you go. Here's your AI agent node. And from there, you can add in your system message or your system prompt. And then you have these legs out of this node where you can add an LLM chat model, you can add a mechanism to retain memory, and you can add your various tools. We can just add in OpenAI. I already have a credential set up here, and let's just leave it at GPT-4o mini. And from there, all you need to do is click open chat and just say hello. And that then hits the AI agent. It triggers the chat model, and you get an answer. So the actual setup of AI agents in n8n is incredibly intuitive and simple. They have done things differently in Make.com. So you have this tab now, which is for AI agents. And when you click that, you can then create an agent. So within Make.com, you kind of define the agent up front, and then you embed it in your scenarios. So let's call this our research agent. You can choose a model. You then have an area for your system prompt, where you can add text. This functionality is in beta, so I'm sure these interfaces will improve. But for example, this system prompt, you actually can't really expand it out. So that's something I'm sure they're going to fix. But if you just type in anything, for example, and click save, then you get to the agent edit page where you actually can expand this out. We'll just put in a basic prompt here. You are a helpful research agent. And you'll see here that you have access to add system tools. So the equivalent here is the way you can add tools to the agent within n8n. So to add tools, then you click the add button. And what happens is all of the scenarios within your account that are set to scheduled on demand or immediately will show up here. So this is the way Make have built their agent, is that the tools are scenarios. And it's the equivalent within n8n. You'll see this call n8n workflow tool. The thing is, within Make.com, you can only use scenarios. You have no other option. Whereas with n8n, you have a lot more options. So yes, you can call another workflow or another scenario, but you can also just trigger a HTTP request tool. So this might hit an endpoint, for example, and get some data back. So this means you don't need to wrap this in a workflow or a scenario. And then you have a very long list of other tools that you can just directly hook into your agent. And again, all of these tools don't need to be wrapped within scenarios. So in a way, this makes the creation of agents a lot easier in n8n. So let's say you wanted to have a Google Calendar tool, for example. You just add that there. And the newer versions of n8n have these great buttons that you can press, which basically lets the model decide what data to inject in here. So we're letting the model choose the start and end date, and let's just give it a description. So you can press that button so that the AI magically populates it. We'll save that, and then we can trigger it. So we'll just say, create an event to review our AI agent tomorrow at 12 noon in our offices. And as you can see, it's created the event. And we have our description at the bottom here, review AI agent. I haven't even tested this. So on the first shot, it did create it, but it's missing the title. The time zone is off on the timing, but all of that can be fixed up then within the parameters of the tool within the agent. And this is an example of another agent we have on n8n, a social media agent. And it's easy to visualize the various tools that you have based off the connections to this node. So needing to create a scenario for every tool is a little clunky, particularly because you get to this point of adding tools and there's no button to create a scenario. You can only choose scenarios already created. So you need to kind of save that, come over here to the scenario section and create a new scenario. So let's do the same thing. Let's go Google Calendar, and we're going to try to create an event, which is here. You need to then work through the OAuth, which is the same as n8n. And from there, then you can choose your calendar. Here you can set your event name, your start date, and end date. Again, the same as n8n. Now, we do want these to be dynamically populated. So just put in test there for a second. And we can't put a test actually there, so we'll just choose a date, which requires a specific date format. And what you need to do within Make.com then is you have these scenario inputs and outputs. So you need to define that the input for this scenario or this tool is essentially an event title, and that's required. And then we have a start date time, and then an end date time, which we'll also have as a date. So if we save that then, which we can't save because we need to set it to on demand. So if we change that to on demand, and we can't change it to on demand because we haven't saved it, so we're kind of locked in a bit of a loop here. Again, this is beta. I might need to just refresh this and start it again. We'll save the scenario first. And now maybe let's add the scenario inputs up front. Now, again, I still can't save because I need to set it as on demand. I can't set it as on demand because I need to add a module. Let's not add the calendar module. Now we can schedule the setting. That's a quirk that definitely needs to be ironed out on the Make.com side. So we'll set this as on demand. We'll save that, but clearly we don't want this module, so we'll go to Google Calendar and let's go back through this process. Google Calendar, create an event. And now that we have the scenario input set, we can then select them here under the scenario input variables. So we have that event title, so drag that in. Start date, we'll click save, and now let's delete that, and that moves the trigger to there. So we'll save that. I've just set it to on demand down here, and you can see it's active, and the scenarios need to be active for the agent to actually trigger them. So now if I come back into my agent, click add, and then I can see my create Google Calendar event tool. So to add this, you do need to add a scenario description. This tool is to create an event in my Google Calendar, so we'll just save that and click add. We'll call this a personal assistant agent. Great, we now have our agent on make.com. The problem is there's no easy way to trigger it the way there is in n8n. You can just click open chat and have a chat with it the way I did earlier. There isn't a native chat interface on make.com for these agents. I don't know, is it in the pipeline, but they position agents more as kind of like a reasoning engine to be used within a workflow. But let's add it to a scenario and actually let's try to trigger it. Create a new scenario. And at a very basic level, let's just set a variable, which is message hello. Okay, so that's that. And then if we type in make AI agents, you can run an agent. And that gives you the flexibility to then choose the agent that you just created, or personal assistant agent. So I think they've kind of overcomplicated things here compared to n8n. With n8n, you just have an agent on a canvas and you just configure it as you need to. Within Make, for example, you're kind of configuring it here in this AI agent section, but then you need to embed that agent into a scenario, and the agent has its own kind of higher level tools, but then you can almost override the tools or give it additional tools here that are only available for this specific instance of this agent. And then you can also override the system instructions of the agent. So I'm not sure why they did it like this. Was it possibly just to have an AI agent section on the menu? I'm not sure, but it does kind of complicate things. Let's add in our user message then. So this would be what we set here in this variable. And we'll swap this out in a few minutes for something like Telegram or WhatsApp. And if we click run once, it's going to OpenAI. And then in the output here, you can see the response is, hello, how can I assist you today? So that's essentially the same response we're getting here for the same message. Not having a chat interface to actually trigger this, though, makes it quite awkward to test it. So let's now test out our Google Calendar tool that we built. So can you create an event in Google Calendar for tomorrow at 12 noon to review our AI agents? Click run once, and there you go. The event has been created for tomorrow at 12 noon. Let's check the calendar. So I found the event in my diary, review AI agents. It actually set the date as the 14th of November 2023, which clearly is wrong. It's April 2025. So within the system prompt of the make agent, we need to say the current date is X. And this is another problem, which is you can't add variables to this system prompt. I will probably need to do it here in the override instructions area. So additional system instructions, the current date is, and then let's just search for a date. Yeah, it's not timestamped. There's now is actually a parameter. There we go. The current date is now. Yeah, and there it is. And yeah, it's just thrown off with the time zone again because we're at +1 here. So the idea of having scenarios as tools, there is a similar concept in n8n, which is to use a workflow as a tool. And what you have here in Make, in terms of the scenario inputs, in other words, what the agent is sending to this tool to trigger some action, is the exact same in n8n. So if we add a tool here, which is the call n8n workflow tool, this does require you to choose a workflow. So let's come in here and we'll just quickly create another workflow. So this is the test tool. And similar to the way this needs to be set to on demand or schedule, here it needs to be set to when executed by another workflow. And then on the left-hand side here, you can define your input schema, which is the exact same as what we did here. So you would set event title, start date, and end date, and those variables would be made available then to a specific module or a specific node. So this could be the create an event. And then to actually populate the start dynamically, you can just drag it in from that kind of input schema. So that's that one there. The end would be that one there. So that's what's really clever about the way n8n did this, is that n8n have lots of modules. So if you look at Google Calendar, you have all of these actions. But instead of requiring you to actually create a workflow each time, you can just embed the actual module directly. And that's a really nice kind of user interface, I think. So onto our scorecard, which has the best UX in setting up agents? I think hands down it's n8n. It's a lot more kind of intuitive, a lot more mature, and I'd be interested to see how Make.com try to improve their workflows around creating scenarios, and because it's very clunky at the moment. If you'd like to get access to any of the automations you see in this video, then check out the link in the description to our community, the AI Automators. Next up is interfaces and triggers. So within n8n, if we look at the interfaces here, I'm using this embedded chat, and that's really intuitive to actually test out your agents. Of course, you're not restricted to that, so there's lots of different triggers that you can create within n8n. So if you look at add another trigger down here, you could trigger via webhook call, you can trigger it on schedule, you can trigger when executed by another workflow, which then enables multi-agent teams. There's even form submission triggers. So you could have a custom form, for example, and that custom form, when populated, could actually trigger your AI agent. The chat that we've been using down here can be made available publicly. You need to activate the scenario for this to work. And this could then be embedded on a website, for example, as a customer service chatbot. And of course, there's lots of modules that then can operate as triggers. So if we come in here, for example, the WhatsApp module has various triggers that you could send in messages and get responses. Telegram is another one. Slack is another one. So there are lots of ways of triggering AI agents in n8n. The chat one in particular is a game changer, I think, because a lot of use cases for AI agents are chatbot related, either embeddable on a website as a customer service bot, or it could be a support bot in a knowledge base somewhere, or an internal bot deployed onto a company's local network. So to trigger an AI agent on make.com, like here I'm just setting a variable for a message. You could have that as a scenario input. So what is the message? And that way then you could just get rid of this, and then the message that you're passing here could be that scenario input. And if you try to run this, then you'll get your message pop up here, and then you can add in your message as you want, and that will then trigger it and you'll get your response back. But clearly very clunky, and that's not a back and forth conversation you're having like what you're having here with this chat interface. There are other triggers then, so let's turn off on demand. If you look at add a module, there's a whole host of triggers that you can use. So again, the examples I used before, WhatsApp, you can have a watch events module that watches out for messages or images coming in that you could then send to your agent. You could have a Telegram trigger, so watch updates, add your webhook in, and then you would hook it in like that. And again, this is an issue with make.com, is you can only have a single trigger for a scenario. You can't connect that up as well, the way we were able to have multiple triggers on workflows within n8n. And the lack then of a native chat interface means that there isn't anything publishable that you could embed onto a website. So instead, you probably would need to use a webhook or a custom webhook. You would save that. That gives you a URL. And from there, then you could link that up to your Make AI agent to generate some sort of response that you would then use a webhook response to send back to a front end. The problem with this, though, is that you need to build your own custom front end. You don't get an embeddable chat like you get here. You would basically need to build this part custom, and then the web service calls from that custom kind of front end chatbot would then need to hit this scenario, this webhook, and work through the agent. So way more complicated, unfortunately. And the way Make.com promote this new functionality is less so based on that kind of chatbot use case, and more based on kind of like an embedded reasoning node within a scenario or within a workflow. And this is a good example of it here. This is our video automation system available in our community. And we have this router set up with lots of different filters based off the type of trigger that was coming in from an Airtable. And this is a real programmatic, deterministic automation. We're defining the exact behavior based off a certain trigger. Whereas what I think Make.com are doing with these AI agents is to add in a level of autonomy around decisions. So instead of a monolithic automation, all kind of controlled from this router, you could just have an AI agent sitting there, and that AI agent could have different scenarios. So this track could be one scenario, this could be another, this could be another, and then it changes the architecture of an automation like this, where you're leaving it up to the AI agent to make a decision as to which track or which scenario to trigger based off what input it received. So that's quite an extreme example, but a more realistic example, maybe something like a Gmail module that's looking out for new emails to come through, and that AI agent would then have the ability to carry out actions based off the contents of that email. So maybe one of the tools of that agent may be to automatically unsubscribe from an email, or maybe to draft a reply to an email and save it within Gmail, or perhaps to create an event in the diary based off what just came through from an email. The alternative way to do that without having an agent there would be a more router-based automation that would require something like an LLM, chat completion, that would output some sort of structured data, and you would then need a router, and the first track would be unsubscribe, this one would be draft a reply, this one would be create an event in the calendar. So effectively, the AI agent is replacing all of those with a new reasoning system with tools. So onto our scorecard. Who wins here? I think it has to be n8n, because n8n doesn't just support that kind of use case of an embedded reasoner within an established workflow, but it also offers the opportunity of having an embeddable chat interface. Having the dynamic forms is pretty cool as well on n8n to trigger the agents. Outside of that then, a lot of the triggers on Make are the same as on n8n. You have your WhatsApp, your Slack, your Telegram triggers. There are Gmail triggers on n8n as well as Make. So a lot of the module specific triggers are there too. In reality, there probably is more triggers in Make than n8n, but it probably isn't enough to actually win this round. Next up then is LLMs and Reasoning. So if we jump back into Make.com and go to our personal assistant agent and click on agent settings, you can see that you have a variety of models that you can choose. Now, a quirk here is that you can't change the model provider once the agent is created, and it says you need to create a new agent. So that is a constraint. It's not the end of the world, but it does remove some level of flexibility on swapping in and out models. And then to create a new agent, you then choose a different connection. So here's the Gemini connection. You have 2.0 Flash, 1.5 Flash. For Anthropic, you have 3.7 Sonnet, Opus, Haiku, etc. 3.7 Sonnet is a reasoning agent. So let's test that one out here. So this is going to be our reasoning agent. And we're going to say, use your reasoning powers to construct a reply. Reasoning agents are crucial in AI agents to actually get intelligent responses back. They do take longer, they do cost more money, but if you provide lots of different tools to an agent, or you're running a multi-agent system, having a reasoning agent is going to get you dramatically better outputs, no matter what platform you use. So we'll save that one. We won't even give this one system tools. I just want to see can it actually use reasoning. So we'll create a new scenario. We'll add our AI agent for reasoning. And the message here will be, what is the meaning of life? Let's try this one. So we'll save that and run it. So we're getting a response back, but it's not actually using reasoning. Whereas if I try Claude 3.7 Sonnet here, I have the ability to enable thinking. So let's ask the same question now. What is the meaning of life? And we are getting JSON output here, but you can see the thinking is coming back. So to actually tighten this up so you're getting text as opposed to JSON, I think you just do edit fields, text. So we're getting the same response, the profound philosophical question. But here it's definitely using thinking, which is what I wanted to see for a reasoning test. And then you also have the ability to provide a thinking budget, which here is set to 1,000 tokens, as well as a max number of tokens for the model itself. So it doesn't look like thinking mode is enabled by default for 3.7 Sonnet. So there's a little bit of a lack of flexibility there. Also, the lack of flexibility of swapping out the models is a little bit disappointing. If we look at what models you can use for these AI agents in Make.com, you can choose the various ones from OpenAI, Anthropic, Mistral, Cohere, Grok, XAI, Gemini, and then they also have a catch-all for the OpenAI API compatible providers. So this does cover a lot. Obviously, you don't have local options because you can't deploy Make locally, but that's quite a decent list and would be kind of similar to what you have here within n8n. There's possibly slightly more here. Some of the more enterprise ones, such as Microsoft Azure or AWS Bedrock are there, Vertex Cloud. And then, of course, there's Ollama Chat. So if you were running this locally, you could use local inference with Ollama. So you do have more options with n8n, both at the enterprise level and at the local level. But I think that the middle ground models are quite similar between both platforms. So back to our scorecard. Unfortunately, this is only going one way at the moment. I'll be giving this one to n8n as well. Next up is prompt engineering. So if we look at the configuration for the agents in Make.com, it's all built into this system prompt here. So there's a definite issue that you can't add variables here. Like this is just a text area. There's no way to add in dynamic information. When I tried to add in the date, for example, I had to do it at the scenario level. But if you look at the additional system instructions here, you can see in the example they provide, use customer name within 2 curly brackets when addressing customers. And if we just add in, this is the date again, just as an example. And if we re-trigger this, yeah, you can see within the execution steps, the system message is what we set at the agent settings level, but then also appended then is that information. So you really can't have anything dynamic within this system prompt. It can only go within here. And within that, then you have your standard functions that you can use in Make.com, such as switch functions, if functions, various operators. It's not possible to use code, but you could use a module like OCodeKit. So if you had a very complex system prompt that you really needed Python or JavaScript to actually generate, you could generate it using this and then just drop in the output into the system instructions there. But it really isn't flexible enough for kind of highly dynamic system instructions or system prompts. The system prompt in n8n is quite straightforward. So you have it here at the AI agent level. If you set it to expression, you can drop in dynamic information like that. Because n8n is low code, you also have the ability to add in lots of other information. So today, for example, is today's date. So you could do like that. You can also use different operators, like logical OR operators or ternary operators within this field. You could dynamically create a system prompt here using a code node, which is this one. And then you can use JavaScript or Python to actually work through some logic to output the right prompt. So lots of different approaches that you can use on the system prompt front. A lot of flexibility there. I forgot to mention max iterations. So this is a setting that's available on both Make and n8n. So you can define how many turns the AI agent can make to achieve an outcome. We went through this in our previous video on agentic RAG, where an agent could pick and choose which data sources to use to build out context for a blog automation. So that's the same there. You could specify the number of iterations an agent will run through before stopping, and that's also available here in the agent settings, the recursion limit. I've set to 300 there, which is quite high. I wouldn't run it that high. So to score this, n8n is definitely more flexible in the sense that you can have dynamic variables within a system prompt. You can also do this in Make with the additional system instructions. You just can't do it at the agent settings level. Within Make, there are various expressions and functions that you can use to help dynamically populate that out, similar to n8n. So while there is slightly more functionality on the n8n side here, I think I'm just going to mark this one down as a draw. It's almost feature parity. Next up, we have Tool. And as I've already touched on, tools in Make.com's agents are effectively scenarios that the agent has access to. And then there's also additional tools that the agent can access depending on which scenario the agent is embedded into. So n8n doesn't have this feature, because agents are just a little bit simpler in n8n in that they're just embedded on a canvas. And if you need to use that agent on another workflow, you just copy and paste it. But the limitation on tools only being scenarios is something I've already covered. Whereas if we look at this social media agent, you can see that here we're actually triggering a workflow, which is our fetch stock photos workflow, which goes through a number of nodes to achieve an outcome. Whereas here we're just hitting a HTTP endpoint. And this is just a GET request to this URL. And as I demonstrated before, if you click on Add Tool here, there's a long list of tools available for agents to use. That being said, within Make.com, if you take their scenario as a tool approach, then technically every module that's available within Make.com could be used within a tool. This is just the reality that Make.com have more integrations with more services than n8n does. This list is a lot shorter, for example, than the previous list on Make.com that I went through. So having built a lot of workflows in n8n, I usually go to the HTTP module quite a lot to interact directly with the API endpoints of various services because there might not be a native tool. So actually, I think I'm going to score this one as a win for Make.com because there just are a lot more out-of-the-box modules that you can hook into, whereas with n8n, you generally need to hit the API of a service because there may not be a native node already there. Both Make.com and n8n offer the ability to hit a custom endpoint like what we're doing here. So you have these native HTTP requests, and they exist both in n8n, but also in Make.com. If you add a module, for example, there's a variety of modules that you can use here to hit arbitrary endpoints, where you just drop in the URL and you post to it, add headers, inject a body, etc. So I think that's a win for Make.com. Next up is memory and sessions. And if we go back to our AI agent on Make.com, for example, if we click on the memory leg of this agent, you'll see that there's a variety of different options of how you want to persist the memory of the conversation. A simple memory, for example, is essentially just loading it into RAM, and it's not going to persist outside of that. But you have other options. You can use Redis, you could use Postgres chat memory, as well as a couple of other options. And if you go to simple memory, you have the ability to set a session key. That could be fixed, or you could have that as a variable, and you have some logic around setting that. And the other thing is you can set a context window length. So how many interactions should the agent remember, which is crucial when you're keeping track of a conversation. On the Make.com side, you have very little flexibility on the memory side of things. So if you go into the configuration of the agent on a canvas, you do have the ability to set a thread ID or a session ID. So with this, you can track different interactions based off what the trigger is. So if it was WhatsApp as a trigger, it could be the person's phone number that triggers the scenario. And that way, then they have the context of that conversation throughout the engagement. And I think that's what this iterations from history count is. I think it's the amount of interactions that are retained in history. I've gone through the full Make.com documentation and I haven't found clarification on that one, but I think that's what that is. So on to a winner for this. Make.com is very bare bones, but at the same time, it works brilliantly for beginners. Beginners don't want to get lost and try to figure out the mechanism of memory, and they probably don't need the flexibility of going to the likes of Postgres or third-party memory services. You do have the ability in Make to retain sessions based off IDs, or it creates a new ID if you don't set one. So Make.com isn't actually bad in this regard. It's just completely abstracted away from you. With n8n, you have a lot more control, but then with that comes a little bit more complexity. So I probably would mark this as even because I think for the use case of beginners, this works perfectly fine. But then with the n8n, you have a huge amount more flexibility around all of this, which is more likely what you would need for more sophisticated agents. On to knowledge and RAG. And I was struck by how there wasn't a single mention of RAG in Make.com's announcements around these AI agents. And if you think about what an agent does, an agent has an LLM brain, it has tools that it can trigger, it has knowledge that it can use to base its answers off, and it has memory. So they are the key aspects of an AI agent. So not to even mention agent's knowledge, I think was a little bit of a misstep. That being said, if you look at an AI agent in n8n, there isn't a knowledge leg. Knowledge is derived from tools, and that's what these vector stores are here on the right-hand side. So if you wanted to give this agent access to, let's say, your Pinecone vector store, you can just click that, and then it can retrieve documents, as you can see there. And from here, you just choose the Pinecone index where everything is actually saved. And there's just a huge amount of functionality around this. So this is our vector store tool. You can choose an embedding model. So it could be OpenAI text embedding 3 small model, for example. And essentially then any communication that's coming into this agent, if this tool is triggered, the query is rewritten, and then an embedding or a vector representation of the query is sent to the vector store to retrieve the most similar results, and then that's fed into the context of the agent to come up with the response. n8n has a huge amount of features around loading documents into vector stores. So this is our agentic RAG ingestion workflow, which I covered in one of our previous videos and is available in our community. And here we're taking web pages that we crawled, and we're then injecting the markdown of those pages into a vector store. And we're loading the data here using this document loader, and we're using a particular chunking strategy called recursive character text splitting to actually create chunks. We're using the OpenAI's embedding model, and then all of that is sent into the vector store. I have covered RAG in make.com in this video here, where I walk through this scenario which actually upserts vectors to Pinecone's vector stores. So there is functionality in make.com for this, but it's seriously lacking on the chunking side of it. In this use case, I was simply uploading rows from Google Sheet into a vector store, and I wasn't really chunking anything. I was just, each row was a vector. And there's no native chunking functionality in make.com, whereas here, for example, there are different options for splitting text. You have token splitters, recursive character splitters, or you could use your own custom logic to actually split text and create chunks to go to a vector store. And that's the power of the code node in n8n. This is some JavaScript that I worked through with ChatGPT, and that can chunk in a relatively intelligent way to provide higher accuracy with the retrieval of RAG. The best I was actually able to do using the native features of make.com was this basic chunking, which is just simple regex. And this is very clunky. Like, this is splitting words halfway, there's no overlap. So this is not going to result in decent retrieval. So I think this is a major problem of make.com when it comes to RAG and knowledge in general for agents. They need to create native modules to help with the embedding and the chunking of documents. Otherwise, you'd have to rely on platforms like OpenAI, who have a vector store feature, and the module in make.com allows the ability to add files to that. I've covered this as well in a separate video on the channel. This is incremental updates to a RAG vector store, and it's using those OpenAI modules to actually keep files up to date in the vector store. So within make.com then, if you wanted to provide knowledge to an agent, you could give it access to a tool, let's say. In other words, you could create a scenario that would take as an input a search term. So let's say that's the search query, which would be required. And then you could use an OpenAI module to actually search that vector store. Now, there isn't a query vector store option here, so you'd have to make an arbitrary API call to OpenAI's platform to actually send that query in to get back the top K results. So as you can see, it's not very intuitive, and you are relying on third-party services. Whereas within n8n, there's just huge functionality around vector stores, loading data into vector stores, querying data with vector stores, and then using different embedding models. Here we're using OpenAI. You could use Cohere. You could use a local embedding model or a fine-tuned embedding model. So we have a definite win here for n8n on knowledge and RAG. In terms of output formats, make.com are positioning these agents as to be embedded within workflows. So a key part of that would be the need to actually get structured outputs. It's very typical in our scenarios on Make to require JSON as an output format, and we would define the exact JSON that's needed. So you could put that into these system instructions. You could say, we require the output in this format, and you could define that. But there's no option here to force it. Whereas within n8n, for example, if you click on the agent, you have an option to require a specific output format. And if you click that, then you're able to add an output parser to the agent. And you have different options for output parsing. And let's say you could provide a structured JSON object, for example. So here it could be state and cities. So then once you add that, you have this new leg now on the agent called output parser, and you can hook up that output parser with that format. And that then requires the agent to generate the output in that format. There's also an option for an auto-fixing output parser. So it's not just a case of providing the output schema, but then you can also hook up another LLM to essentially send it back into the AI to actually get it to fix the output if it didn't produce it correctly the first time. So then that's how that configuration will be set up there. So this way you're getting highly reliable outputs from the AI agent in a structured sense, which can then feed into follow-on modules, and that's what improves the resilience of automations. Make.com definitely need to build functionality around forcing JSON as an output format and giving the flexibility to create a schema so that then follow-on modules can actually rely on what the agent is producing. That's not there at the moment. So it's another win for n8n on the output format side. For multi-agent teams, on this channel, I created a personal assistant agent that controls 25 sub-agents. That's a free n8n template that you can access within this video here, and I'll leave a link for that in the description below. And this is that agent. This is HAL 9001. It uses Telegram as a trigger, and then it also responds in the iconic voice of HAL from the movie 2001: A Space Odyssey. And that's using text-to-speech using the Speechify API. The way this works, though, is that this large multi-agent team are all available as tools. So here we have different supervisors, and if you click into any one of these and open them up, they in turn have sub-agents that they can trigger actions. So the communication supervisor has access to an email agent, a Slack agent, and a Twitter agent. And if you jump into our Slack agent, the Slack agent then has various actions that it can complete. So the architecture that I'm using here is basically using agents as tools. And in theory, this is possible with Make Agents. So you could have an agent which will be your director agent. You would set a model, you would give it a prompt, and then you would need to create another agent which would be a supervisor agent, and then you would need to embed those sub-agents in scenarios. So then this director agent actually has access to the scenarios that include those agents. So it is possible in theory to do it. It's definitely clunkier to set up than n8n because you have this kind of abstraction of AI agents outside of the canvas. The other issue is timeouts, because if these sub-agents take too long to actually work down the tree to carry out the action and send the message back up to the main agent, this agent workflow itself might time out. Within Make's AI agents, they have this feature to continue the scenario run while the agent is working. And if you click yes to that, you get to specify a webhook URL. And they say, set this to yes if your agent will take 3 minutes or longer to finish. So 3 minutes may be the hard limit here for the agent to wait for a tool to respond. The maximum execution time of a scenario on Make.com is 40 minutes. But obviously the limitation there is on the tool of the agent itself. There is more flexibility within the self-hosted version of n8n on workflow timeouts. However, I do think the HTTP node in n8n has a max timeout of 5 minutes. So generally speaking, timeouts is a problem for multi-agent teams in both Make and n8n. There possibly is a little bit more flexibility though within n8n. As the Make AI agent was only released late last week, and multi-agent systems are quite complicated, I haven't spent enough time testing the Make AI agent to actually tell you one way or the other where it stands. But in theory, it's the same mechanism of using agents as tools. So I'll leave this one as unscored until I spend more time on it. For debugging and error handling, generally there's better features in n8n for this anyway. So for Make.com, I have an AI agent here connected to WhatsApp. So if I just trigger it to say, scrape a specific website, and you can see the specific execution data by clicking on the bubble. So here's the response from the AI. I have a tool hooked up to scrape a website, which is using Gina.ai. And it's saying that it can't fulfill the request, that it does not accept a website name, it requires a URL. And if we click into that tool, you can see in the history that it was never actually executed. So this must be the agent determining from the message that the URL hasn't been provided. Now I didn't add www, so let's try it again and I'll do that. And this is the nature of building AI agents, is there's so much back and forth needed. Okay, I've actually provided the full URL this time. And the fact that it's taken longer means it's clearly gone to the tool to get the result. Okay, I'm sorry, but I can't provide any output because the tool doesn't return any information to me. So, okay, this is good. We're getting some level of feedback. And if we click into here, and here we can see that there was a success. And there is the data. So it did actually crawl the website. So I just need to go back into the canvas now and specify a scenario output. So here we'll say this is the website summary, and then description is summarize the scraped website. And now with this scenario output set, then you just add another module and you use the return output module, which then gives you that website summary, and then you can just drop in the variable that you're getting back from the service. In this case, it's data, and then back into our agent. And now that scenario will provide that output, which it has done. And there's the summary. And then that's what's passed back to me on WhatsApp. So you can get a sense of the debugging and the error handling involved there. The problem is you have these various runs in history, And if you jump into any specific one, you can see the data that was used within that execution, but there's no way to retest that flow with that data. And that's what you can do in n8n, which is super powerful. So if you go to a workflow and click on executions, you can see various previous execution runs. You can click on them to see what data was involved in that execution. And for previous successful runs, you can just click this copy to editor, which brings in all of that data into the workflow, where you can just pin it and test it again. And for workflows that produce errors, you can actually click this button, and that allows you to retry the original workflow with the data or with the current version of the workflow with the data. So there's just huge amounts of flexibility in debugging n8n workflows. Once you get the hang of it, it is more advanced, but it's a lot more dynamic than just the static list that you get on make.com. The other thing to say for n8n is for error handling per node, you have the ability to set it to retry on fail. And that's hugely important when you're dealing with LLMs that can actually time out or can produce overloaded errors. And you have different options then where you can just stop the workflow dead, or you could continue it with a different leg. So for example, if this one throws an error, it could follow down a different track. The other thing is you can set error workflows that trigger, which could notify you that the actual execution has run into a problem. So there is a lot of functionality in n8n for error handling. There isn't any settings here at the agent level for that type of gracefully retrying and exponential backoff. You have your standard error handling in Make, which if you right click and add an error handler, there is the ability to use break error handlers or resume error handlers and carry out different actions within the stream. We use error handlers quite a lot in our automations on Make. So there is some decent functionality there, but probably not as fleshed out as n8n. So for this one, again, I'm going to go with n8n for debugging and error handling, particularly around that ability to reload previous execution runs. For deployment and privacy, I think straight away we can just give this one to n8n for the simple reason that you can run n8n in the cloud, you can self-host n8n on your own server, or with services like Render or Railway. You could host it with AWS or Google Cloud. You could run it locally or in Docker. So then with that comes huge data privacy, because you could have it completely cut off from the rest of the world, hidden behind firewalls. Whereas with make.com, you only have one option, which is to use their cloud platform. So it's a lot simpler from that perspective, but you have a lot less flexibility. They have a full privacy section on their website where they talk about privacy by design. And there is some decent privacy features built into Make, such as the ability to turn off logging once a scenario is active and up and running. That way you're not saving potentially sensitive information per execution. And on their more expensive enterprise plan, they do have enhanced security, such as audit logs, compliance support, single sign-on with company-specific identification management systems. So I think that's a quick tick to n8n for huge flexibility on deployment and privacy. On to more cutting-edge things like MCP. I did a video a few weeks ago on MCP agents in n8n. This was used in a community module and it gained a huge amount of traction. And even since then, n8n have brought out their own MCP client, as you see here, as well as an MCP server, which can be used to integrate with the likes of Claude Desktop or Cursor. If you don't know what MCP is, then definitely check out my video. I'll leave a link for it below. But now with the support of the entire industry, it does look like MCP is going to be the go-to standard when building agents and connecting them with tools. Even Zapier has created an MCP product, allowing agents to connect to the wide variety of modules and connections they have on their platform. So Make is already behind the curve on this. They definitely need to bring out some sort of MCP solution, even just to keep up with their competition. So again, another green tick for n8n. So on to the last one, pricing. And I think you may know the direction this one is going. Make's pricing is based on operations. So you can see the price for 10,000 operations on the core plan is $9 a month. Within their AI agents, you have your connections to the various LLM providers. You are going to pay per inference via these platforms anyway. And that's the same with n8n. You're going to be connected to the various platforms and you just pay the bills there. So really we're talking about the cost of running these agents and building these workflows. And it's on an operation basis within make.com. For n8n, because there's an open source version of n8n, you can download it for free and run it yourself. And that way you're just paying for the server cost. You don't pay per operation. Within n8n Cloud, you do have a budget of workflow executions per month. At the starter plan, it's 2,500. But you could have unlimited steps or unlimited operations within that. And you can have 5 active workflows. Within make.com, you can have an unlimited amount of active workflows. So n8n Cloud and make.com do have different commercial strategies. But if you're operating your n8n agents or your workflows at a level of scale, it's worth quickly getting off n8n Cloud and just setting up your own server on the likes of Render or Railway or Alestio, where for even as low as $5 a month, you can get your instance up and running without any limits. So that's clearly a lot cheaper than paying per operation and then needing a specific monthly plan on make.com. So again, I'm going to give this one to n8n. And here's our results. So n8n agents are clearly the winner It's a much more mature platform, a lot more flexibility, a lot more features. It's definitely more cutting edge by keeping up to date with the latest in MCP. And definitely the only area that it's losing out on is its tool use. The fact that Make.com has just thousands of integrations, n8n just can't compete with that. So that really is where Make.com wins. But I think on every other front, n8n is better. And coming into this, I assumed AI agents in Make.com would be easier for beginners, and n8n will be better for kind of intermediate to advanced use cases. But actually, I'm surprised by how poor the UX is on Make.com's agents. It's really clunky to actually set these up. Whereas with n8n, you just drop an agent node onto a canvas, hook up a chat model, hook up a few tools, and away you go. So it's super simple on n8n, and I think Make have possibly dropped the ball a little bit on that by abstracting the creation of the agent from the scenario. They should just dump the creation of the agent and just have them all in scenarios. It'll make life so much easier for people to actually use. I hope this video was useful. Let me know in the comments below what you think. Do you think Make agents are better than n8n? If you'd like to get access to any of the Make.com or n8n automations that you saw in this video, then check out the link in the description to our community, the AI Automators, where you can join hundreds of fellow automators all looking to leverage AI to automate their businesses. Not only do you get access to these automations, but you also learn how to customize them to meet your own specific requirements. We have a packed schedule of events, all of which are recorded so that you can play them back if you missed them. We have over 100 templates on both Make.com and n8n, as well as a number of courses including our n8n masterclass. Check out the description below. We'd love to see you here. Thanks for watching, and I'll see you in the next one.